was developed, of course, for sound, for stereo equipment and stuff like that. But then they realized that they could figure out attenuation and all this other kind of stuff we could use with the same thing. dB uses logarithms. Anybody know what a logarithm is? I have two types of logs. We're going to use what we refer to as the common log. Okay, so let's look at let's see what this is using a micrometer. We're going to use what they call an outside micrometer. We got several different micrometers that's available to us. So we got an outside device used to precisely measure thickness of blocks, outer and inner diameters of shafts and depths of slots. Outside, typically used to measure wires, spheres, shafts, and I don't know what the other was supposed to be, because I kind of dropped off right there. Inside, commonly used to measure the diameter of the holes of the boards, and then depths is used to measure the depths of slots and steps. So this is our three types of micrometers. So this would be the outside micrometer. This is the one that we're going to use.
I can't remember how you set it back to 0, or how they do the scaling on the number that you get. So I know it's very, very precise.
Yeah, very precise. Ours is too. Ours is in inches, and that's nice because our American wire gauge is in inches. But you can get these things in millimeters. You can get them in different. Can't get my camera to work. Yeah, that's what I did. Either that or it's already running. Right, okay. No, I don't see it. Now let's try this. Might be that it just don't have. There we go. So this is our inside mic. Ours can go, has a pretty good range. And I don't know who makes this, but it's actually put out by Craftsman long before Kmart started selling. So this is our inside mic right here. And what we can do is we can put different ambles on here to get different gauges. So we'll look at the different parts. And this one's actually off quite a bit. So we need to recalibrate this. Now, what we can do is we can change different, we can put different ambles in here to get, so this guy here could go all the way out to 4 inches. Of course, we're not using that. We're just going to use it for wire gauge. This one won't let me switch between applications. So this is the parts right here of the micrometer. So we call this guy right here, we call it the what? Thimble. This guy on the very end back here, we call this the ratchet cap. Then it's got a locking lever. Our locking lever is a little different than what they've got there. So our locking lever is wires. It's actually right here. So right now I can turn it pretty easy. I go over and lock it. Now I can't turn it. So normally, once you get your measurement, you want to lock it, and then that way when you take it off, it's not going to move when you come up here and read it, right? That makes sense? So the thimble is, so what we do is we come up here, we put what we want to measure in here. And then we come over here and we start turning the thimble until it starts getting close. Then when it gets close, we move over to the ratchet and we start turning it until it clicks one time. And when it clicks one time, that means that's where you need to make your measurements at. And then we'll come up here on this barrel right here and we'll make our measurements off this right here. Are we okay? Now this is the way our micrometers are set up. So when I turn it, it starts off with 0, and then the big numbers go to 20, and then it comes back to 0, which would be 25, right? Everybody understand that? Yes or no? And then we take that and we subdivide it into major units. So each major unit is worth what? 1, and each small unit is worth 0.025. Okay? Now, depending on which way it turns, so what would I be measuring right now? The first thing I'm going to do is I'm going to read this number, right? Understand? And then I'm going to move over to what? This number, then, right, and this one, and then this one. Now this would be, right, not 16. It looks like, I'll have to see which way it turns. I think it's not at 15 yet. You got one click above 15? So it's 0.001. Yeah, so it's one click, it's one above 15. No, it's on this line right here, right? Yeah, this is not lined up right. Let's look at some more. First, turn the thimble until the space between the anvil and the spindle, the two rods, is wider than the device to be measured. Slightly wider, right? Okay. Y'all know what the anvil is. So here's the anvil. So the anvil is the stationary part. The spindle is the part that's moving up and down. And what we're going to do is we're going to turn the thimble until it gets close. Right? You understand that? Now when it gets close, then you're going to move over to the ratchet cap and start turning that. Right? So it says, first turn the thimble until the space between the anvil and space, the two rods, is wider than the device to be measured. Second, place the device to be measured between the anvil and the spindle. Third, turn the thimble with the ratchet cap until the rods contact and the ratchet cap clicks what? Once. Fourth, tighten the locking wheel. Fifth, remove the device to be measured. Sixth, read the measurement. Are you okay there? Okay. First, we need to determine how many major divisions is showing on the barrel. In this example, there are 5 major divisions showing, right? Because 5 is the mark that's graded. So this is the 5, right? You understand that? Then I do what? So what would I do? I'd come up here and I'd write down what? 5, right? And then I'd come down and do what? How many we got? 1, 2, 3. That's going to be what? 0.75, right? Right? 0.75. And then I come up and read this. And then I would add what? And my measurement would be what? Or 5.87. Right? Are you okay? Did I do that right? Next we need to check, so this is going through. Next we need to check the minor divisions, right? So here's where we came up with what? 0.075, so I didn't do, so what I should have done is I should have said 0.5, then that would be this, then I add what? 0.075, right? Everybody okay? And then I would add what? So I'd be 0.5, 0.075, 0.012, and that would come up and give me 0.587, right? 587 millinches. You okay? 5.87, 587 millinches. So what's this one? I'm listening. So I'm going to say 1. Why am I going to say 1? Right? Now here's 1 right here. Huh? I'm sorry. So it's going to be point what? Now 0.5, right? Then I'd add what to it? 2.2. So 0.072. Is that right? Is that what you got? What you got, Brian? What you doing like this?
2 clicks above 20.
2 clicks above 20. Yeah, but this is 25. This is 0. It's kind of like a cycle. Okay. So 0, this is 360, and it's also 0. Well, this is 0, but it's also 20. It's also 25 coming around that way direction, right? Understand that? 0.072. Is that what we got? It's whatever it is. Okay, what would this one be? I think. So, well, this is 6 right here. No, I'm sorry, this is 6 right here. So it'd be what? Yeah, that'd be 5, right? And then it'd be what? Plus what? 0.075 plus what? 0.014. What we got? Yeah, because it's below 15, so it increases going this way. That's what you got. So it's increasing going this way. So anything below this would be on the other one, right? 0.589. 0.589. Are you okay? What would this one be? What you got? 0.747. About 747, Rich. Sometimes I amaze myself. Everybody okay there? 747 or 747 milliinches. Good. What y'all got here? What, 635? Are we okay? Everybody got that? We okay? Point 635.
The one we use at work, it's got an actual rotary wheel. So point 3 digits.
Nancy's got some that's got a digital readout on
The environment we work in is noisy, so we ain't better hear it. So once we get it on there, we take that measurement, get it in the computer. There we go.
it. So what was this one? This is actually off our mic right here. What's it next? Odds are it's not, I don't know if you can see this line right here or not. Looks like,
Would that be called
Yeah, you can see it. You can
Yeah.
see it.
it's just one over to
2.75 plus.
So what you got? 0.2,
Plus 275
plus 1, right?
Plus 026. Oh, it's on one.
That's only one.
Oh, it's on one.
We got us on 1, right on 1.
Yeah.
0.2, 0.276. Oh, I didn't show you that. So what we're going to do is, we got some bags in here.
He added that one. Yeah, 75. So you got 2, you add 2 to 0.075.
Yeah, 0.2.
Yeah. 0.075 is the next number.
Yeah.
And then it's all one.
Yes, so that's wrong.
0.00. I mean,
Why would we?
yes, it is. That one over there is
So
small
why would
amount.
it be when there's, yeah,
The same way we've been adding.
okay, the 0.5 and just start back over again.
You got 3, half that 2, you got 3 things going.
I got that. You looking at that? You got 9 line up there.
That line right at 1.
Okay.
0.00.
No,
No. This the only line you're looking at.
I'm looking at that, but I'm saying, how
It's
you
right on
count
this
that?
line. You ain't gotta look at this. You're looking at this.
So you start back, they'll count every one. So they're gonna-
No, it's right on one.
Yeah, I'm saying, but it's 1.
But see, them other problems they had on one
Okay,
of
I
these
see, that's
roads.
0.001.
But it's right on 0.0.
Yeah, I see that. No, you see, I looked at it, like, when you say 20, 21, 22, you kept counting, you got
But these numbers don't come into play. You looking at only this line, right? It's the only line you looking at.
So that basically goes to 0.001.
0.001.
Why even matter? Get that zero right in there at that point. 0.25. Just do it.
If you find a big number, you just move on down and add them all together. Tell how old these things are.
We've had it for a long time.
It's Robot, ain't it?
Craftsman. I don't know who made them.
Back before Kmart.
I thought it came out for a minute and it didn't have no shot.
Kmart, they were competitors then.